Okay, so molecules are made of nonmetals, but also sometimes metalloids. Sometimes. Not very often, but every once in a while. Okay? So they're made of nonmetals and sometimes metalloids. And if you've forgotten where those are on the periodic table, the nonmetals are all those ones that are sort of like the pink color there. And the metalloids are the blue ones. So basically everything to the right of the staircase, okay, with just a few on the left, but I wouldn't worry about those ones. I won't give them to you anyway. Like I'm not going to give you antimony, for example. Whoops. Like I'm not going to give you antimony because it's just, there's no compounds that are really common with antimony in them. Okay, so don't worry about them. Mostly just know that it's nonmetals. And those two nonmetals can be the same. Like an iodine and an iodine. And if they are the same, what kind of molecule is this? This is a molecule of an if the atoms are the same. Anytime you have same atoms, it is an element. Yeah. Yeah? And because we're going to write the word molecule a lot, I would like to introduce you to my shorthand way of writing, shortcut way of writing molecule. Capital M, capital C. Okay, MC is short for molecule. You can have a molecule where the atoms are different. We've got here an H and a Br. If the atoms are different, this is a molecule of what? Compound. Okay, but they're nonmetals. H is a nonmetal, Br is a nonmetal. Is this one a molecule of an element or a compound? This one here. That is a molecule of a compound. What would the formula for this be? H2O. How about this one here? Is this a molecule of an element, or is it a molecule of a compound? Everybody should be able to tell me. Of an element. And what would the formula be? Everybody should be able to tell me. What should the formula be? S8, because there are, whoops, not 8, S8, because there are 8 S's. S8. How about this one? Is this a molecule of an element or a molecule of a compound? That's a molecule of a compound, because we've got carbon and chlorine. We've got different elements. And the formula for this one? Now, sometimes it's hard to tell, but usually if you have one in the middle, that one comes first. Okay? what is the formula for this going to be? If you've got one in the middle, it comes first. So we're going to have C, and then Cl4. Okay, so this is CCl4. I'm not going to necessarily make you write the formula for compounds from the pictures because it's hard for you to know at this point in your chemistry careers which element comes first. Okay? All right, and then over on the right-hand side, there's some really complicated ones. Like this one I think is caffeine. Caffeine. There's a lot of C's, a lot of H's, some ring structures, some O's. Okay, that is an organic compound because it is mostly based on carbon and hydrogen. We've got this one here, BF3. Okay, that's a case where we have a metalloid. The boron is a metalloid. We have IF5. Do you see how the singleton goes kind of in the middle usually, and it is usually the one at the front? And then we have, ooh, isn't this one fun? It's like a little pyramid almost, P4. So those are our molecules, all made of nonmetals or sometimes metalloids. You should be able to tell whether you have a molecule of a compound or a molecule of an element. Which goes to the point, molecules can be elements. So not all molecules are compounds. Some molecules are elements. And that includes all of your diatomic elements. But the key thing is if they're elements, all the atoms are the same. Now we're going to take a look at a couple of these up close. We're going to zoom in on hydrogen, nitrogen, and oxygen, and you're going to look at this here, and this here, and this here. Do you guys remember what it's called when we have one line in between them? That is a single covalent bond. What about nitrogen? We have 3 lines. We have a triple covalent bond. And oxygen, we have 2 lines. What's that called? That's a double covalent bond. Tell your partner how many electrons are in a single covalent bond. And then you can tell them how many electrons are in a triple covalent bond and how many electrons are in a double covalent bond.
Like the fluorine, the line is really long.
Oh, I don't think so. I think it's just because, no, I don't know. I don't know. I know that it's physically, it is longer than oxygen and nitrogen because those extra electrons cause a greater pull. Okay. And hydrogen is small because the hydrogen atom is a lot smaller. So maybe it's actually being a little bit representative of what they're actually like. That's my guess. How many electrons in a single bond, single covalent bond? 2. How many in a triple? 6. And how many in a double? 4. Very nice. Okay. There are atoms that exist as diatomic molecules without looking at them. So cover up your paper or fold it over or something and see if you can tell your partner who are the diatomic elements. You can use your periodic table if you need.
So HON is hydrogen, oxygen, and nitrogen. And then the halogens are...
And where do you start? Point on your table. Point on your periodic table. Where do you start?
Yeah, I mean, you already started. Yeah, but
Yeah.
you started at 7. HON,
Okay, if you were successful, give yourself a little pat on the back. If you weren't successful, learn it for next time because I think on Thursday we're going to have a quiz on covalent compounds. Covalent. Okay? Thursday. You get a periodic table, yes. Okay. There are elements that exist as polyatomic molecules. You are not responsible for memorizing these. Okay, what does it mean that it's polyatomic?
more than 2.
More, 2 or more. Or sorry, yeah, 2 or more.
It's not maybe like every other.
Yeah, so it's like basically everything else that's not diatomic. If it's bigger than 2, yeah. You could even put the 2 in the polyatomic category if you wanted to. Not responsible for memorizing. So you do not need to know that phosphorus comes as P4. You do not need to know that sulfur comes as S8. Some molecules are compounds. Not all of them. Tell your partner why not all of them.
Some of them are elements and compounds. It has to be made out of more, one or 2 or more different types of elements. I'm not going to stop. But so it's a molecule. Why are compounds? Actually, I'm going to have a lie. Why are all molecules not compounds? Okay. Crystal lattice is not a molecule. Yeah, but it's like asking why all molecules aren't compounds.
I'm going to ask the other question soon. Why are all compounds not molecules? I'm going to ask that also. Okay.
Yeah, that was the other way. Yeah, exactly.
Okay, so here are some compounds, and here's a little bit of enriched stuff for you. Water is not enriched. Everybody should know water is H2O. But if you want to be enriched, you should know ammonia is NH2. 3.
What is
Ammonia it's a weak base. It's used in a lot of cleaning products. So like Windex, for example, contains ammonia. Lots of cleaning products are bases because bases feel slippery. And so they'll cause the dirt to like slip off of things better. Okay? Carbon dioxide, CO2. And we'll be learning about that when we do our naming. And then if you want to, again, methane is CH4. But those are optional. You don't have to know their names or formulas. That would be an enriched question. It would be probably on the test. I don't know if I'll put it on the quiz. We'll see. I have to make up the quiz because I haven't had one on that before. Yeah. So we're good? Okay. Oh, look. Memorize the name and formula. It will probably be on the quiz. Yeah. Memorize the name and formula for ammonia and methane if you want to. Molecules are made of 2 or more atoms. I think we knew that. Atomic oxygen is not a molecule. It's a single atom. Diatomic oxygen is a molecule. What kind of bond are there in molecules? Molecules are held together by covalent bonds. Tell your partner what it means for a bond to be covalent.
Tell me. They share right, and then yeah, so then they merge their so then they have to stay together.
So if we have a covalent bond, what do they bond together? What kind of elements? Nonmetals. And metalloids. And what happens with the electrons? The electrons are shared. And we don't just share single electrons, we share pairs of electrons. One shared pair is a single bond. And that would be your 2 electrons. 2 shared pairs is a double covalent bond. And that would be your 4 electrons. And 3 shared pairs is a triple bond, which is going to be your 6 electrons. Sometimes I get people asking, can we share 4 pairs of electrons? Technically it's possible, but what you're doing is you're cramming all of those negative charges, 8 negative charges, into the space between the 2 atoms. What do electrons do to other electrons? They're negative and negative and negative and negative and negative and negative. What does negative do to negative? They repel. So it's quite unstable to have that many electrons in one place. So given any opportunity, one of them will break open and attach something to something else that's further away. So here we have our shared pair . That is a single covalent bond. And that gives oxygen. How many electrons does oxygen start with in its outer shell? How many does it start with?
And it's outer shell.
In its outer shell. 1, 2, 3, 4, 5, 6. How many does it want? It wants 8. How many does hydrogen start with in its outer shell? 1. How many does it want? 2. So let's see, how many does hydrogen end up with? 1, 2. Yeah, so 2 for hydrogen, and then how many for oxygen? We got 1, 2, 3, 4, 5, 6, 7, 8. So everybody has a, what do we call that when it's got a full 8 electrons?
Yeah, that's right. You're right.
It's stable, or 2 for hydrogen. But that is called a something something.
That's what you said. Because they're saying all correct and negative comment. Yeah.
A complete what? Octet. Yes, you're right. So the whole point of covalent bonds is to get a complete octet or 2 for hydrogen. Now, here is an electron cloud model. So this is a Bohr model up here. This is the electron cloud model. And we got 1 electron in the cloud of hydrogen, 1 electron in the cloud of the other hydrogen, and when they come together, those 2 electrons are in the middle. What charge are these electrons? They are negative, yes? So I'm going to label them negative and negative. What charge are the nuclei of the hydrogen? They are positive. What does negative do to positive? Attracts. The negative shared electrons attract the positive nuclei. And that actually happens on both sides. And don't worry if you can't get this in on this diagram. I've got a better one in another section. Okay, so if you're like, I don't know how you're managing to draw it on there because I can't make my picture as big as you did, Miss Spence, right? But feel free to like highlight in there. Now, that attractive force what is the name of that attractive force? That is an electrostatic force. Is that a different force from ionic bonds, or is it the same kind of force? Same kind of force. Every single thing that holds atoms together, that holds molecules together in chemistry, is because positive attracts to negative, all due to these electrostatic forces. So in the ionic compound, it's between a positive ion and a negative ion. In a covalent bond, it's between the shared electron and the positive nuclei. Okay, so our shared electrons and the positive nuclei, that gives us our electrostatic force. Here's an oxygen. Oxygen, remember, has only 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Will it be happy if it just shares 1? That would get it up to 7. So instead of just sharing 1, it has to share 2. So here we have 2 pairs of shared electrons. What do we call that? We call that a double bond. Okay, so there's our double bond. Nitrogen is in group 15. 15. Nitrogen is in group 15. How many valence electrons does it have if it's in group 15? 5, right? Group 15 has 5. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. Okay, so here's group 15. So it has 5 valence electrons. 1, 2, 3, 4, 5. And you can see that there are 3 of them don't have a partner. Yes? This one doesn't have a partner. This one doesn't have a partner. This one doesn't have a partner. These guys don't have partners. 1, 2, 3. So they're all going to pair up. Okay? So we end up with 3 pairs of shared electrons. And if we have 3 pairs of shared electrons, what do we call that? We call that a triple bond. I got a question for you. If I have a nucleus and I have 2 electrons, and I got a nucleus. And let's say I have a different one and I've got a nucleus. And now I've got 1, 2, 3, 4 electrons. So now we're drawing in the force. That's our electrostatic attraction. Which of those 2 bonds is stronger? If you just had to guess based on what you see. Which one do you think would be stronger? Any guesses? Anyone want to take a guess? Guessing's good. Remember, it's just a guess. Doesn't have to be correct. Should we vote? Should we call this one A? And this one B? Okay, do you guys remember how to do A? Okay. And you can do B. And if you really have absolutely no idea, if you don't even want to guess, you can just be like, oh, how would you expect me to know at this point, Miss Spence? Oh my gosh, right? So you can choose either A or B or I don't know yet. 5, 4, 3, 2, let's vote. Okay, I've got some representation on both sides. All right. What I want you to do is I want you to imagine that we have some bungee cords. And these little guys here, imagine that that is like a bungee cord. Which one is going to be harder to pull the two apart? One that's attached by 2 bungee cords or one that's attached by 4 bungee cords? 4 bungee cords is going to be harder to pull apart. Okay? So that means that a double bond is stronger than a single bond. So a double bond is stronger than a single bond. And if you don't like the bungee cord model, you can imagine if I had 2 magnets pointing at a piece of metal. Okay, it's attracted by 2 magnets, but what if I had 4 magnets? Would that attract it more or less? It's going to attract it more. Okay, I'm having a hard time holding these all. I'm not doing a very good job of it anyway. But if you have 4 magnets, it's going to attract it more. The problem with magnets is that they all want to hold on to each other as well. But that's going to hold on to that thing better than just 2 magnets. Yeah? So it's the same sort of idea. Okay, molecules. This part is enriched, so if you're like, I am bored and I would just like to take a little nap for a moment, just put your head down on your desk and have a little nap. Okay, totally fine. Molecules have a definite composition. This is enriched. What that means is that they contain a specific number of each type of atom. A specific number of each type of atom. Unlike a crystal lattice. Exactly. A water molecule is always 2 hydrogens and 1 oxygen. Ammonia is always 3 atoms of hydrogen and 1 Nitrogen, that nitrogen didn't show up very well. Let's make that an N. Unlike a crystal lattice, which can be bigger or smaller. And if you put your head down for a nap, you can wake up again, because we're back to non-enriched stuff. Ionic compounds do not form molecules. So that gives us the answer to the question, are all compounds molecules? Are all compounds molecules? And remember, ionic compounds do not form molecules. So the answer is no. Ionic compounds are crystal lattices. Okay, only covalent compounds are molecules. Ionic compounds are crystal lattices. So if you have a nonmetal and a nonmetal, you get a molecule. But if you have a metal and a nonmetal, it's not a molecule. What would we call this thing where we have one sodium ion and one chloride ion? This is called a formula unit. Okay, so if you have nonmetal and nonmetal, you get a molecule, and those atoms are bonded covalently. If you have a metal and a nonmetal, they're bonded ionically, and you get a formula unit. And do you remember how I said if you're having trouble drawing those forces and the lines? Do you see here we've got that electrostatic attraction here and here? That's our electrostatic attraction between the shared pair of electrons and what is this part here? That's the nucleus. So the electrostatic attraction between the nuclei, do you guys remember what nuclei is? It's the plural of nucleus. So the nuclei are the positive parts. What are the negative things? The shared electrons. What kind of a bond is that? What kind of bond do we have there? Covalent. This is a single covalent bond, yes. Now that's different than on the other side of the page. On the other side of the page, we have an atom and an atom, and watch the electron. It moves from here to here, and it ends up over here. And now we have a positive ion and a negative ion. So this is an attraction between the positive ion and the negative ion. What type of attraction is that between the positive ion and the negative ion? You know it. Electrostatic. What type of a bond is that? That's an ionic bond. Not a molecule. What would this be called, this thing here together? Formula unit. Now, if you want to, once again, put your head down, have a little nap if you're not interested in this. Molecules always contain an exact number of each type of element. They have a definite composition, yes?
Yeah.
Can you see that this crystal lattice, this small crystal lattice, has many less ions than the large crystal lattice. Okay, so that's one way that you can tell that an ionic compound is not a molecule. It takes place between a metal and a nonmetal, and that's not a molecule. It involves bonding between two ions, not between the shared electrons and the nuclei. And the last thing is that it doesn't have the ionic compound does not have a definite composition. Okay. What does the prefix inter mean? Between. So if you have an intermolecular force, what's it between? Between molecules. And how do we abbreviate intermolecular forces? IMFs. Excellent. Guess what type of attraction gives us intermolecular forces? It's caused by electrostatic attraction. Yeah. Do you want to call it ESA?
What about electrostatic force? Is that different from attraction?
No. The thing is that electrostatic attraction refers to only half of the force. It's like the positive and negative. Electrostatic force could be a repulsion as well. Okay, so when we're talking about bonds, we're always talking about the attractive part of it. But an electrostatic force could also be repulsive. Yeah. So these are between molecules, and you know what? Bonds are stronger. Covalent bonds are strong. Ionic bonds are strong. Intermolecular forces are weak. Okay? Ionic bonds are strong. Covalent bonds are strong. IMFs, intermolecular forces, are weak. Do you remember that video of that guy melting salt?
Oh, that was fun. Yeah.
How high did that temperature have to get to melt the salt? Really high. That's because he was melting salt. What kind of bonds were in the salt? Ionic bonds. And ionic bonds are strong. So you need a big, high temperature to break them. You need to put in a lot of energy to break those. Do you remember what happens when water boils? Do the atoms come apart? No. So those covalent bonds don't break when water boils. What's breaking when water boils? The IMFs are breaking, so the forces between the molecules are breaking. So here, for example, we have some ammonia. And this bit right here, that is our weak IMF. Those little lines in the NH3, those are strong covalent bonds. Hey, if we just keep going till the end of class and you don't have any homework, is that a deal? Okay, cool. Let's keep going till the end of class. All right. So again, here's our strong covalent bond. But you don't get to pack up early. Okay, you start packing up early, I'm giving you homework. Ooh. So we got our strong covalent bond. And we have our intermolecular force that is weak. So if I was to start heating this, Ignore that. So basically, when a substance melts, or it boils, or it sublimes, what does it mean to sublime? It goes from solid to gas. It is the intermolecular forces that break. So who breaks? Intermolecular forces break. Do the covalent bonds break? No, the strong covalent bonds do not break. And look, here is some sublimation. And again, here are our intermolecular forces. These are our weak intermolecular forces between the molecules. And these little lines in here, those are our strong covalent bonds. When we heat it, which ones break? The weak IMFs break and the strong covalent bonds do not break. And we go from CO2S to CO2 gas. And let's leave it here for today. Thank you guys so much. There is no homework. Yay! And you can go get your phones.
Marked all of them, but I didn't total them. I'm sorry.
That's okay, because I still got to mark that one anyway. Thank you so much.
You're welcome.
Thank you guys so much. You were awesome today. Of course, you're awesome most days. So.
What? I think 136. Yay.
How many like, is it possible?
Oh, special. I don't want to.
Is it possible?
You are using it.
Oh yeah.
Like,
Oh yeah. Oh yeah. We got 1, 2, 3, 4 more tests. Yeah. I know the last 2 minutes are a little shorter.
I always forget her name. She also is talking about guys. She's like, hey, this guy, I bet, and I talked to him, and I created
Vivian, your hair looks super cute today. It looks super cute every day, but it's just different today. So it's a different cute.
Okay, why not?
Oh, that's mine.
oh, I
Yep.
thought it's lost and found.
Yep, that's me. Who knows? I could have left it here and then it would have been lost and found. I've been like, where did I put it? Oh no. Hi. Okay. Okay. Are you working? No, but like, who's your teacher? Okay. And what concentration?
just using hydrochloric.
Yeah, but I need to know the concentration because otherwise I got lots of different concentrations back there.
So it's 0.27 to 1.37.
Okay.
I mean, not more.
Let me go see what we got. Right here. Yeah? Okay, cool. Okay, so I can also need to, so you need to find something. How long do you need to cook it for? Okay. Because quite frankly, if you wanted to do it like tomorrow morning, like if you wanted to come in here during break and start it, it could just sit in my food. Do you know what I mean? Right? And then you don't have to worry about, I will babysit it. But I can't tonight because I got a birthday party I gotta go to. But yeah, if you wanted to do it, say tomorrow morning, come in a break. Yeah, I think that might be better. What's that?
Wait, do you want to do it tomorrow morning?
You can do it tomorrow morning. What you can do, if you want to, is you can bring it, come in a break, and then you can set it up and just put it in the oven, and I can leave it. Does that make sense? Okay, so what we'll do, if that's okay with you, is we'll just put this aside in the input so it's all set and ready to go. Yeah, and then if you want to do it tomorrow, set up a break. Does that make sense? Well, it's like 15 minutes. How long is it? But I'll babysit it during block 2. Right? Oh yeah, no. Come in during break, and then I'll babysit it, and then you can come back in at lunch and collect it. Yeah? Okay, cool. Because, like I was saying, I got a birthday party to go to today. Otherwise, I would stay and mark some stuff, but I got to get out of here. So, perfect. All right.